Hello students. What I'm going to do now is I'm going to walk through the solutions to the assignment. This is for students who are struggling to complete their corrections properly. You can follow along and get your corrections completed, and please listen carefully to the explanation as well as the presentation so that your final assignment is of the suitable quality, right? Of course, for students who have already fully understood this chapter, well done. Let's move on to the more advanced stuff. You please carry on. All right. So for those who need extra explanation, here we go. We're going to begin, okay, by solving this pair of simultaneous equation using substitution method. So the first thing I'm going to do is I'm going to call this equation 1 and this equation 2. Now, because the question wants us to use the substitution method, if I have a term that is independent, that means the coefficient is actually equal to 1, it makes our life a lot easier, right? Such as this little x over here. So since it's on its own, I'm going to start from equation 2 and make that x the subject. So from 2, x is equals to 4y minus 6. I'm going to call this equation 3. Okay, so what it means is that now whenever I see the variable x, I can replace it with 4y minus 6. So I'm going to do that for equation 1, right? So I'm going to sub, just write sub, equation 3 into equation 1. So I have 5x, now the x, I'm going to replace it with 4y minus 6 plus 2y is equals to 3. So 20y minus 30 equals, plus 2y first equals to 3. That means 22y equals to 33. So y equals to 3 over 2, or if I prefer to write it as mixed number, is 1.5. So we found our y. Now we need to find the x, right? So we can go substitute y equals to 3 over 2 into, let's put it into equation 3, right? Because x is already the subject there. So x equals to 4. Now my y is now 3 over 2 minus 6. That means x equals to 0. Okay, so therefore, solution, x is equals to 0, y is equals to 1.5. Right, next example here. We are supposed to solve a pair of simultaneous equations using elimination method. So same idea. Let's begin by naming the equations. Then a quick observation will make us realize that 9x over here is a multiple of 3x, which means if I take equation 2, I multiply by 3, the 9x actually match up. So we can actually use elimination method here. So that's what we're going to try to do, right? So I take 3 times equation 2. So we have 9x minus 12y equals to 30. Then I'm going to call this equation 3. So since now this 9x and this 9x matches up, I'm just going to subtraction, right? So I'm going to take equation 1 minus equation 3. So 9x minus 9x give us 0. We don't need to write that down. Negative 5y minus negative 12y give us 7y. And then 2 minus 30 give us negative 28. So that brings us to y equals to negative 4. So now I have y. Let's substitute it back in to find my x. So I'm going to substitute y equals to negative 4 into, you can choose any one. So let's put equation 1. Why not? Right? So 9x minus 5 negative 4 is equals to 2. So 9x plus 20 equals to 2. 9x equals to negative 18. X is equals to negative 2. Therefore, solution, x equals to negative 2, y is equals to negative 4. Okay, now moving on to tier B. Tier B, the first example we have is to solve a pair of simultaneous equations using the elimination method. So let's begin by naming the equation 1, equation 2. So now I can't eliminate it directly because the coefficient doesn't match up, but we can do something about it, right? So what we can do is we can make a quick comparison. 3y, 2y, maybe I can find the common multiple, which is 6y. So I'm going to go 2 times equation 1. That will give us 8x minus 6y equals to negative 2. I'm going to call this equation 3. Then we go 3 times equation 2. That will give us 15x minus 6y. 4 times 3 is 12. So I'm going to call this equation 4. Right? Then after that, I can just repeat the process. Equation 3 minus equation 4. 8 minus 15 is negative 7x. The negative 6x get eliminated. Negative 2 minus 12 is negative 14. Therefore, x is equals to 2. Now I can substitute that back in. Substitute x equals to positive 2 into, I can choose any one. Let's put it into equation 2, why not? Right? So 5x is now 5 times 2 minus 2y equals to 4. Right? So that means 2y is equals to 5 times 2 minus 4. 2y is equals to 10 minus 4 is 6. So y is equals to 3. Then write down solution. Therefore, solution x is equals to 2, y is equals to 3. Right, next example. Solve the pair of simultaneous equation using substitution method. Okay, so same idea. Let's start by naming them. Okay, and then we can choose either equation 1 or equation 2. That's fine. So maybe let's choose equation 1. So from 1, what happened is we have 3x equals to 5y plus 7. So x is equals to 5y plus 7 over 3. Okay, we can call this equation 3. It's okay, right? So we're going to substitute equation 3 into equation 2. So what we have is 4 multiplied by 5y plus 7 over 3 minus 3y is equals to 3. Now I'm going to multiply everything by 3 so that I don't have to deal with the denominator. So we have 4, 5y plus 7 minus 9y equals to 9. Expand 20y plus 28 minus 9y equals to 9. So 11y is equals to 9 minus 28 is 19. So we have negative 19. So y is equals to negative 19 over 11. Then we need to get back our x. I could call this equation 4 for clarity. So I'm going to sub 4 into 3. X equals to 5 times negative 19 over 11 plus 7 over 3, right? And then just use the calculator. At this point, you are allowed to use calculator. We will have, let me just write it here, equals to negative 6 over 11. Okay, so after this, we just write down, therefore, solution x equals to negative 6 over 11, y equals to negative 19 over 11. Okay, right, next. Solve the pair of simultaneous equation using substitution method. Okay, we can do that. So we're going to call this equation 1. I'm going to call this equation 2, right? So what can we do here? Well, let's start from 1. So from 1, we can rearrange it so that y is equals to 3x minus 23. And call this equation 3, right? So we're going to sub 3 into 2. So 3x over 3 plus 3x minus 23 over 4 equals to 4. And then what I'm going to do is I'm going to multiply everything by 12, the LCM of 3 and 4. So we will have 4x plus 3x minus 23 equals to 12 times 4 is 48. So continue, 4x plus 9x minus 69 equals to 48. That means 13x equals to 117. X is equals to 9. Then we can substitute that. Sub x equals to 9 into equation 3. We get y equals to 3 times 9 minus 23, which is equals to 4. Therefore, solution, x equals to 9, y equals to 4. Okay, next one. Solve this pair of simultaneous equation using the substitution method. So same idea. I'm going to start by calling it equation 1. I'm going to call this equation 2, right? So from equation 1, we have x plus y equals to 9 after I multiply both sides of the equation with 3. Then I can actually say y is actually equals to 9 minus x. And I can call this equation 3 for clarity. Then substitution method, so I'm going to sub 3 into 2. So what happened? We have 3x plus, now my y can be replaced by 9 minus x, so I'm going to write that, over 5 equals to 1, right? So 3x plus 9 minus x equals to 5. Multiply by 5 on both sides. So 2x equals to negative 4. That means x is actually negative 2, right? So we're going to sub x equals negative 2 into equation 3. Okay, you can see equation 3 is just y equals to 9 minus x. So 9 minus negative 2, which gives us 11. That means the solution, x is equals to negative 2, y is equals to 11. Okay, now let us move on to a different type of question. In this question, they gave us a pair of simultaneous equations, but they give us a solution first. So what it means is that if we just sub in the solution, it should work and declare that mathematical statement to be true. And from there, we actually get another pair of simultaneous equation where the variable is p and q, and we can solve them, right? So what I'm going to do is when, let me write down, when x is equals to negative 11, y equals to 5, that means that p times x, which is negative 11, plus 5, y is 5, equals to q, right? So that means negative 11p plus 25 equals to q. I'm going to call this equation 1. Then what happened? Same thing will happen for the second equation. Q, x is actually 5, negative 11, plus 7 times 5, y is 5, equals to p. So negative 11q plus 35 is equals to p. And we'll call this equation 2. So what happened is p, right? Just change my pen color. P here can be substituted with negative 11q plus 35. So I'm going to do just that, right? I'm going to sub equation 2 into equation 1. Let's see what happened, right? So negative 11, my p is negative 11q plus 35, then plus 25 is equals to Q. So that means 121Q, 11 times 35 is 385, plus 25 equals to Q. So 120Q is equals to 360. Q is equals to 3, right? Then we need to find what is P. So I'm going to sub, let's write that properly. Sub Q equals to 3 into equation 2, right? So that will give us P is equals to negative 11 times 3 plus 35, which gives us where's my calculator? 2, right? Therefore, solution, oh no, in this case it's not solution, right? They just ask us to find the value of P and Q. Therefore, P is equals to 2, Q is equals to 3. There we go. Okay, final example. This time round is some context is given. So computer animation, there's a cat moving in a straight line. You have the height, which is H, and the time, which is the S, right? And then there's a mouse, okay, following another equation. So if we identify the equation, we have one here, and we have another one here. Okay, so the question asks us to find the height, which is just H, and also find the time, which is just S. So technically, if you read this question, it's not very complicated. They just want us to solve it simultaneous equation, because if you understand the meaning of simultaneous equation, it means both this statement is true at the same time. So if they're true at the same time, and this equation gives us the location, it means they actually meet, they are the same location, right? So let's begin. And first step is of course just to copy out the question, right? The equation. 8s minus 3h equals to negative 9. And then we have negative 29s plus 10h equals to 16. So we call this equation 1. I'm going to call this equation 2. You can use substitution method or elimination method. As long as you do it correctly, you will get the same solution. So in this case, let's try elimination. Let's eliminate the h, right? So I can go 10 times equation 1. That will give us 80s minus 30h equals to negative 90. So I'm going to call this equation 3. Then we're going to take 3 times equation 2. That will be negative 29 times 3. What's my calculator? 87s plus 30h equals to 48. Let's call this equation 4, right? So after this, what happened? To eliminate the 30h, I just add them together. So equation 3 plus equation 4, right? That will give us 80 plus negative 87 is negative 7s equals to negative 90 plus 48 is 42, negative 42. So S is actually equals to 6. That means 6 seconds later, after the animation start, they meet, right? But we still need to find the height, the H, okay? So we need to do some substitution, right? Sub S equals to 6 into, let's sub into equation 1. Why not, right? So 8 times 6 minus 3h equals to negative 9. 8 times 6 is 48. 48 minus 3h equals to negative 9. Negative 3h equals to negative 57. So h is equals to 19. So that's our value. But of course, the question did not actually ask us to find h and s. They asked us to find the height and the time. So proper context and statement. Therefore, the cat meets the mouse 6 seconds after it starts moving at 19 meters above the ground. Oops, what happened to my Apple Pencil? It's not appearing. Okay, above the ground. Right, so since it's a word problem, let's answer with proper statement. Okay, so I hope you have been successful. Complete your corrections and look through again. Try to present your work in the acceptable manner. Have a nice day.